Hey guys, this is Akshat Madan. Welcome back to a new video, and I am back with another cool project out there. And this time we are not going to learn AI. This time we are going to learn the blockchain, right? Blockchain plus our favorite Flutter, right? So we are going to make a mobile app, as you can see on my screen, which is going to be the end product of this video. And if you watch this video end to end, you are going to learn a lot, not just this web3 part, the Flutter part, plus a lot of opportunities, right? So one thing I'm very happy to tell you that this video is made in collaboration with NORDEK, which is a leading blockchain powered company, and they are out with some great opportunities for college students and school students also, which I'm going to talk about later in this video. So stay tuned if you want to become a campus ambassador or if you want to get an internship at NORDEK to, be a part of this video, right? I'm going to talk more about it. Right, so do check out NORDEK. They are working on some great blockchain powered projects. You can check their website. It is one of the greatest companies to work with, right? If you are a tech enthusiast, definitely. Okay, so this is something our end product of this whole tutorial going to look like, right? Where we are going to make your own bank, or we can say a expense manager. So what are we going to use in this? Definitely Flutter, our favorite suite Flutter, plus Truffle, which is again a blockchain framework or SDK you can consider, which I'm going to teach you. Then we are going to use Ganache. So Ganache is your private blockchain, which looks like this. And this provides you a lot of accounts with free hundreds and hundreds of Ethereums, so that you don't need to spend your own Ethereum to work on just a small scale or private project, right? So for learning purposes, you do not need to spend Ethereum. We have Ganache and we are going to use this, right? And definitely we are going to work a bit with Node, plus we are going to work with Solidity smart contract, and definitely we are going to work with web3 Dart, which is a package or a plugin to connect your Solidity smart contract with your Dart programming language or Flutter. So this is going to be a big project, a good project for your resume, a resourceful project. So you are going to learn a lot, right? And if you are new to Node Express or you want to learn some backend with Flutter, you can definitely check out my paid course, which is right over here, right? And it covers Flutter, plus it covers TypeScript, Node.js, Express.js, Postman, Render, MongoDB. So a lot of stuff. So it is a full stack mobile app development course. Registrations are still open. You can check that out. The best part will be the community that you get. In the chat section, you can put your doubts. And even if you don't want to purchase the course, that is totally fine. You can be the part of the community for free. So do check out the community link in the description and be the part of the community. And whenever you feel that this course is useful for you, you can buy it, right? Not an issue. Now let's see what is going to be the end product, and then we can start building it without wasting more time. Okay, so definitely you get this page, and here is your balance, right? The current balance in your bank account. So I hope this 16 Ethereums were real, and I could have been I hope that I was a master of these Ethereums, but no, they are dummy Ethereums which are getting fetched from this Ganache, right? And then I can see all the transactions which I made. Let's say today I got my salary, so I can click on this credit and I can say like I got 30 Ethereums today, and I hope this was my salary. So let's say I got salary today, salary from my company, right? So from my company, this is the reason of transaction, and click on deposit. So this is going to get back, refresh the page. So we are going to use block state management for refreshing and for maintaining your state, and this again updates the smart contract. So you will see that okay, this is just like a to-do app, but no, it is not like a to-do app. At the back end, there is no server, there is no database. It is smart contract, it is blockchain, right? So your data is getting stored on the blockchain, and this data and these transactions are coming from the blockchain. That's the part you have to learn, how to make a blockchain mobile app, right? And let's say today my friend says, hey Akshay, you have to give me party, and my 10 Ethereums got used today, right? And today was my birthday party. That will be the costliest birthday party I would have given. So 10 Ethereums I spent today, and let's say I say withdraw. You see it updates the blockchain, and then it shows the balance in real time, right? So that's all is getting it is possible because of block. It is possible because of the smart contract behind it. So this is the whole project that we're going to build today. It is going to be a long video, so stay tuned. And in between, don't forget to miss out the things that I'm going to tell you, some tips and tricks, some courses which I'm out, NORDEK Genesis Program, which is useful for the college students for getting an internship or becoming a campus ambassador, right? So do be a part of this video. Don't skip it. right? Watch this video in parts, but watch it fully. Okay, let's go ahead and start with the coding part. So guys, now let's start building the application, right? So what I'm going to assume in this whole video is that I don't know anything. I just know the tools that we are going to use today for building this decentralized application, which are Flutter, Truffle, Ganache, and VS Code and all. But I don't know what is Truffle, I don't know what is Ganache, and I don't know how to build a DApp, how to write a smart contract, right? Everything we are going to learn from the internet, and then we are going to apply in this video, right? I can make this whole video in 20 minutes also by just showing how I'm doing it, how I'm speed coding it, but that's not helpful for you. You need to understand how to actually debug things, how to actually learn a new concept, which I'm going to show you how to do in this video, because many people ask me like how you learn so many things. And that is my purpose of making this video, that let's assume I don't know blockchain, let's assume I don't know Truffle, Ganache, or how to write a smart contract, right? So let's learn together and then create this project. Okay, so this is my purpose, and this whole strategy I'm following in my course also, which you can check in the in the description. Like, the link is in the description, you can check that out, where we learned the whole backend plus frontend in Flutter plus Node.js, Express.js and all. You can check that out, right? But without wasting more time, let's start building the project. So what I've done here is I've opened the VS Code, I created a new Flutter project, right? Just hit Command Shift P, and we are going to click on create a new Flutter project and just give it the name. And as you know that we are going to make an expense manager Dapp, I have named this app as Flutter Expense Manager Dapp. Code is also in the description, you can check out the link. Okay, perfect. Now what should we do is, before we write any Flutter code, we have to write the smart contract. Now what is a smart contract? Let's go on the internet, let's go on ChatGPT and ask it what is a smart contract. Right, nowadays learning is more simpler, right? Because you don't need to go on Google and search for articles, go through the articles. No, just go on the ChatGPT and ask it what exactly is a smart contract. Now let's try to understand it. A smart contract is a self-executing contract with the terms of the agreement directly written into the code. Okay, so what is an affidavit? Or whenever you have to make a legal contract, let's say you're purchasing some property or you're doing some business contract, you write a contract, right? And that contract is signed by you also and the other party also. Let's assume an offer letter. Whenever you get an internship or get a job, you get an offer letter, right? That means both of the companies, like you and your company, are agreeing on the terms that you are going to work for these many hours in a day, and you're going to get this much money at the end of the month. And for this much will be the probation period, this much will be the bond period, everything, right? That's a offer letter, right? That's a contract, but that's a physical contract, right? You get a hard copy of it, you get a PDF of it. But what is a smart contract? Smart contract is written in the code, right? Whereas those contracts, the legal contracts, are written in simple English language, or they can be in simple Hindi language, right? But these smart contracts are written in coding languages, programming languages. One programming language can be Solidity, right, which we are going to use today, right? Solidity is simply like, if you know Dart, if you know JavaScript, if you know TypeScript, you already know Solidity. Syntax is very similar. We are going to learn from the scratch, right? But when we are going to code the smart contract. Perfect. So this is what a smart contract is. Just consider it like a piece of paper where certain code is written, and everyone in the chain, the blockchain, is agreeing on those terms, and that cannot be changed later. Once it is signed and deployed, it cannot be changed later. That's it. Okay, so as it is written, smart contracts run on the blockchain platforms, typically on networks like Ethereum, Binance Smart Chain, Bitcoin, or others, right? So this is what a smart contract is. It is running on a blockchain. Okay, it is a piece of code which is agreed upon by everyone, and now it is running on the blockchain. Okay, perfect. What it provides you autonomy, it provides you decentralization, trust, security, efficiency. Because that legal contract which you got from the company is still not decentralized, right? The company has provided you an offer letter. That means company has the authority, to change it or like anything, right? But this smart contract is decentralized. No one has authority over it once it is deployed. It cannot be changed, right? So this is how a smart contract works. So in the same way, when we are going to code today the expense manager app, when we write the smart contract, the deposit function, the withdrawal function, the transaction function, once it is deployed, no one can change it. Okay, perfect. So this is what a smart contract is. And first of all, we have to write a smart contract itself. The smart contract for expense management. Okay. And now we need truffle and ganache, right? So what is truffle? What is truffle in blockchain? Okay. So truffle is a development framework. Flutter is a development framework. Truffle is also a development framework, right? For Ethereum blockchain development, we are going to use Ethereum blockchain, right? Because we are going to use Solidity, and Solidity is usually used for building the Ethereum smart contracts, Ethereum based smart contracts. It offers a suite of tools that streamline the process of building, testing, and deploying the decentralized application, which is Dapp, which we are going to build today, and smart contracts on the Ethereum network. Yes, we are going to use both of the things. We are going to use a smart contract also, we are going to build a smart contract also, and we are going to build a Dapp also, right? Truffle provides developers with a set of tools that make the development process more efficient and manageable, right? Okay, let's, this is okay, right? We are going to use truffle to easify or simplify our development process of building this Dapp. Okay, let's agree on this. Okay, now what is ganache? What is ganache in blockchain? Okay, so what is ganache? Let's actually stop the previous question and let's submit this question. So it is lagging a bit today, I'm seeing. So what exactly is ganache? We can actually search on the internet also. It's not like that we are dependent on ChatGPT, right? So what is ganache? Ganache is a personal blockchain for Ethereum development. Again, Ethereum development, because we are going to build a smart contract on Ethereum blockchain, right? So Ganache is a personal blockchain for Ethereum development that allows developers to create private network to test their smart contracts. Once we build some app, let's say Flutter app, we have to test it. Similarly, when we write a smart contract, we have to test it. And for testing a smart contract, you need some ETH, the Ethereum, you need it, right? And obviously, we are poor guys, right? We don't have that much money to try or just try the smart contract and spend some real Ethereums. We don't have that much money. We are poor guys, right? So that's why for helping out the developers, this Ganache came into existence. Ganache provides you a private blockchain which looks like Ethereum blockchain, and there you get a lot of Ethereums. You get some dummy wallets, and in those dummy wallets you get some Ethereums, dummy Ethereums, which you can use to try and test your smart contracts. Understood? Perfect. Ganache also provides a user-friendly interface to view and debug transactions, events, and blockchain states. So it looks interesting. Let's go on Ganache website, right? So you will be saying like, why I'm not starting with the Flutter code? No, it's not required right now. First of all, you understand these things, right? Ganache, truffle, and all. Then you are going to build it up, right? These things are important to understand in this video, not Flutter. Flutter is a small part of this video, right? Ganache, download. We have to download the Ganache because it's a GUI, graphical user interface, right? So click on this Ganache and click on download for macOS, and you can download for Linux and you can download for Windows. Let's click on it. Download. So you see, this is something that you're going to get. You are going to get some dummy wallets, and you can see that there are some dummy Ethereums inside it. 100 Ethereums you get in so many wallets, right? These are some wallet addresses, right? And you can get the private keys of these addresses also, right? Private key is something which should be hidden from others. Only you as the owner of the wallet should know the private key. And because if anyone else also knows the private key, it's like a password of your bank account. If anyone else also knows the password of your bank account, then they can also access your bank account and they can also make the transactions, right? Similarly, in this blockchain thing, in this wallet thing, if you give your private key to someone else, they can also access your Ethereums in your wallet and they can transfer those Ethereums to their wallet, right? So don't share your private key, right? So that's why instead of worrying about this private key and all, Ganache came into existence, where we don't have to worry about these things, right? Because these are all dummy Ethereums. Okay, so let's see if it is downloaded. It is downloading. So it is taking some time. So till it gets downloaded, why my internet is not that great today? Okay, that is fine today. Okay, so till it's till it downloads, we can go on our VS Code and we can start working with the truffle integration, right? So for initializing the truffle, you need to need to learn some basics of Node, or you just need to learn actually one command, that is to initialize your basically your truffle, right? So let's do that first. So guys, now let's try to install Truffle or set up the Truffle within our Flutter project, right? So I'm going to open the terminal, and inside this terminal I'm going to write npm install -g, that is globally install Truffle, right? Truffle, and just hit enter. So let's wait for it. So let's wait. You see some errors are there, and these errors are some permission errors, right? So if you also get these errors, first try with this command npm install -g Truffle. If you get the same permissions issues, so what you have to do is you say sudo, that is super user you're calling, so super user do uh, npm install, that is the same command -g Truffle. Now it is going to ask you the password of your computer, so just enter the password and hit enter, and then your Truffle initialization or installation will be done without any issues, right? Okay, so let's wait till it installs Truffle within our so Truffle is basically the node dependency. So if you go on the internet and search for npm Truffle, you're going to get the documentation of npm Truffle, right? So you can also see the command is here, this command is here, right? And you can just read about it, what exactly is Truffle, how it works. But you don't have to, because everything we're going to cover from the scratch, right? Now this is good, it is installed without any issues. Now you have to say Truffle init, right? And you see it is initializing the Truffle inside my Flutter project. So let's wait, starting init. Let's wait, let's wait. It can take some time because it is generating some folders, it is generating some files. Now you will see some extra folders and files will be generated inside this. So let's wait. Taking some time. So till it downloads, I can show you the chat box that we have, and in this chat box itself you will find the code of this video also, like, right? So after this video I'm going to put the code link in this chat box, and I'm going to post it. So you must join my community, which is free of cost. You should join it, and people are asking doubts, and I'm happy to help them out, right? So you are also it is recommended that you join my community, so that whenever you have any doubt, you don't have to put a message on LinkedIn or Instagram and you have to wait for my answer. You can just put the question here, and other people are also helpful to help you out. So that's recommended. So it is taking some time. Is it requiring yes from me? So okay, so it required yes from me, so I have put y, yes, override the test, and it is now done. Okay guys, okay, so I missed this thing because I'm a beginner. Okay, so now you see that contracts folder is new, and I can see one .get keep file. So don't worry about it, we will learn like how to use it. And I can see one migrations folder in it, which is again empty. Contracts folder is here and migrations folder is here. And definitely we are going to have node modules folder because it is now a node project, right? And we are also having truffle config.js file at the end. So I think my photo is hiding that part, so let me yeah, put my photo or put my video here for a minute. You see this truffle config.js file. So this is again a helpful file which we are going to utilize to set up the Ganache blockchain, right? So this is also important. And then you see package.json file, right? And inside it we only have one dependency, that is our truffle dependency. Okay, and these two folders I showed to you, which is migrations folder, contracts folder, and again node modules folder. Okay, so now Truffle is initialized, right? And we are ready to write our first smart contract. So congratulations, your Truffle is initialized. Till here you should have it. Before you watch the further part of the video, I'm recommending you that you pause the video here, set up this much in your Flutter project, right? And then you can continue the further part of the video. So this you have to do, then you can watch the further part. Okay. So let's write our first smart contract. So in this contracts folder, I'm going to create a file which will be called expense manager contract dot sol. So sol means solidity. So we are going to use solidity programming language, and to use this, just go on extensions and search for solidity. Search for solidity, and you're going to get this extension, right? So install this extension. Okay, let's wait for it to install so that it can, find out the errors or mark these errors with red lines, and it helps us to, compile it also. So solidity, right? So okay, let's wait for it to install. It is installing. Till then, we can go in the expense manager contract and let's start writing our smart contract, right? So first of all, what you have to do is, this is an empty file. First of all, you have to write the license, because whatever we are writing in the smart contracts, most of the smart contracts are open source, right? And it is usually recommended to open source your smart contract. It shows that your smart contract, what you have written, is legit, right? Because we are talking about decentralization here, and in decentralization, open source should be, it strikes a mind, right? So you have to open source your smart contract, and for that you have to write your MIT license, which is an open source license identifier. Okay, so write it like this: slash slash spdx dash license identifier say MIT, right? So this is something that you have to write it down, and this shows that your smart contract is following this or comes under this license, right? Okay, that's it, nothing else, no rocket science. Then you can start writing your smart contract. In OP we have classes, right? Class here means contract, so write your contract. So in normal, in JavaScript or in Python or in Dart, we write class. Here we write contract. So contract, what is the name of your class, or what is the name of your smart contract? It is expense manager contract. So expense manager contract. And is it has it downloaded our Solidity? So it is still downloading. Okay, let's wait. After that, it will show some colors, so that you can, how it, VS Code shows some colors for your words, that it will start showing. That's why I'm installing that extension. Okay, now after this you need to, so this is your class, and inside this class you can have your variables, you can have your constructors, you have your functions, you have your structs, everything you have inside this contract. Okay, now what we have to do is, we have to define some variables, and we have to define some functions. So my first thing, I want a model, right? That model should show my transaction, right? In Dart also we have models, right? So that way we have to, in that way we have to think. And for Solidity, in Solidity you define structs, right? Like in TypeScript we defined interfaces, right? We have also done this in our course also, right? Where we defined the interfaces for tweets, and then we created the tweets application, right? Now you see the Solidity extension is installed, and now it is showing some colors to my words, right? So now I need a transaction model. For modeling you need structs. So struct, what I'm defining the struct for a transaction, because I'm creating a expense manager application, and in expense management you need transactions. So struct transaction. For every transaction I'm going to have an address, right? Because here we are not talking about user IDs, or like in normal application we define user IDs, that this user ID has these many coins, or these many this much money, right? Here we talk about addresses, right? Because everything, like a smart contract or a person or a wallet, everything in blockchain is defined by addresses. So address, user. So every user is going to have an address instead of a user ID. So address. Then the amount. So amount I'm going to define it in unsigned integer, right? You can define it in float or double also, but let's define it in integers. So you int amount, for what amount the transaction was done. Then you need the reason why this transaction was done, right? Let's say you purchase some vegetables, or you purchase some stationery items, then you have to define the reason. So string reason. Okay, and after that you need the timestamp, at what time this transaction was done. So time stamp. Okay, so this is your simple struct, right? So this is my simple struct, or you can say this is a simple transaction model, right? Now after that you are going to need the address of the owner of this app, right? Or owner of the smart contract. So that you define, you first of all define the data type, like here I have defined the data types, and then I'm defining the variable name. So user, amount, reason, and timestamp are the variable names, and address, uint, string, and uint are my data types, right? So if you want me to teach you Solidity from the scratch in like 4 hours bootcamp or 5 hours bootcamp or 6 hours bootcamp, let me know. I'll create a whole video, right? So address, and then you need to define that this is going to be public, right? Because everyone should know that who is owning this smart contract. So address public, and then you need the variable name. So owner will be my variable name. Okay. So these two things we have defined in our smart contract. Now what you need to define is you need to define the constructor. That is the first function which runs whenever your smart contract or your class is initialized, right? Or when you create an object of the class, right? In OOP we do that. Constructor. So constructor you define by constructor keyword, and inside this constructor function I'm going to say that owner is going to be owner. That means this owner of the smart contract is going to be message.sender. So msg.sender. Now what does this line mean? This line means that whosoever has deployed this smart contract, or whosoever is initializing this thing, or taking the initiative of this thing, or I think you have understood. Whosoever is deploying the smart contract should become the owner, right? So as I'm going to deploy the smart contract, or I'm the sender, I become the owner of the smart contract. So that's the first thing that gets initialized in the constructor of your smart contract. Okay, so this is what this means. Now I'm going to start writing my functions. First function is going to be your deposit function. So function deposit, right? Sorry, deposit function. And inside this deposit function I'm going to write some code. Then my withdraw function. So second function is going to be withdraw function. Again spelling withdraw, right? So withdraw function, right? This is going to be my next function. My next function is going to be function get balance. Like what is the balance of the smart contract, or what is the balance of this user, right? So balance, and this is again going to be one function. And another function will be function get transactions count, like how many transactions I've done. So transactions count. And next function is going to be get a transaction, like the information about a transaction. So function get transaction, and this is again going to take some parameters and return some value. And last function is going to be get all the transactions, right? So function get all transactions, like whatever transactions this user has done, fetch all those transactions, right? Okay. And the last function is going to be, let's say you want to deliver this contract or transfer this account to some other person. Let's say I'm dead and I want to nominate someone, right? So that's for this function. Function change owner, change owner. Okay. And this is also going to do something, right? Now after, so this is okay, and now it's time that we start writing these functions one by one. Okay, so let's start writing the functions one by one. So guys, before we start writing all the functions, I'm very happy to announce that Team NORDEK, which is a leading company in the DeFi space, is offering one NORDEK Genesis program for students from colleges and schools to become their campus ambassador. So all those who are looking for internships and some content creation internships, or be a face of some company, this is for you. This opportunity is for you. So hear from Priscilla, who is from Team NORDEK, and let's hear from her like what she wants to say about this NORDEK Genesis program.
Hi, this is Priscilla. I'm here to talk about NORDEK Genesis. So, NORDEK Genesis program is an initiative by NORDEK, an EVM compatible blockchain to upscale the young minds and empower future innovators like you. If you're new to blockchain or have an experience in Web3 space, we have various opportunities for you. We have run multiple hands on workshops and roadshows in multiple education institutions in different cities, and there are many more coming up. If you're a student, then we have four types of programs for you. One, if you want to be the front face of NORDEK and represent us in your campus, then we have Campus Ambassador Program. Second, if you are building something and want to be an entrepreneur, we have student startup grants and support to grow in the ecosystem. Third, if you're a job seeker, you can leave your resumes with us under Nordic Careers. Fourth, if you want to simply learn from different departments under Nordic, like BD, product marketing, etc., then you can join us in our apprenticeship program. To learn more about us, go to www.nordic.io/Nordic-Genesis. So why wait? Join us to rock your Web3 journey.
Okay, that's great. That's a great news. So I hope NORDEK team sees you as their campus ambassador. Now let's go ahead and continue the coding part. So now we have to write down the functions, right? So first of all, we have to write down the deposit function. So in this deposit function, we have to accept some money and we have to accept the reason for depositing this money, and then we have to update our transaction. Also, we have to create a transaction. So let's start writing down the code for deposit. So in this deposit function, definitely we have to accept the amount. So int amount. Then I'm going to define the string memory reason. So why memory? So memory we define whenever we want to store something in the memory, like not in a variable, like, right? Just for some time we have to store this value, right? The reason value have to store just for some time. Now you have to make this function as public so that anyone can call it, or I can call it from outside. And you have to make this function as payable. Payable you define when you have to accept some Ethereum, whenever your function has to accept some Ethereum, right? So here I have to accept the amount, right? So that's why this is a payable function. Okay, so payable, and inside this I have to say require. What is required? So this require keyword you use whenever you want to set a condition, right? If else condition, right? So this, the requirement for this function is that the amount that you have got should be greater than 0. Amount should be greater than 0. Otherwise you are going to throw an error which is going to say deposit amount should be greater than 0. Okay, this is my requirement. Now after that I'm going to say transactions. So transactions variable I have to create, which is an array of transactions, right? So what I'm going to do is I'm going to create an array of transaction which will be public variable. So public transactions, right? Empty. Okay, now I have to add a transaction in the array. So transactions dot push one transaction. So one transaction. Okay, now inside this transaction you have to define these 4 things. That is the user. User is nothing but me, so message dot sender. So message dot sender, and basically the message sender means the one who is calling this function, who is depositing the money in your account, right? So message dot sender. The amount, so amount is going to be the amount parameter, and then you need the reason. So reason also we have got it. So reason, and then you need the timestamp. So timestamp in blockchain or Solidity we define it like this. So block dot timestamp, right? After this you have to emit one event. So for deposit also and for withdraw also I'm going to have 2 events. So event deposit is going to say, so event deposit it will be deposit. It is going to take the address from where you received the money. So indexed address. So it will be from where you got the money. What was the amount? So you int amount. Then you need the reason. So string reason, and then you need the timestamp. So it will be uint timestamp. Okay, so this is my one event. This amount will also be underscore. Now you need the same event for withdraw. In withdraw, change the event name. From will become 2. Rest everything same. Okay, now when we define the events, we define it to emit them. So once I have done my thing for deposit, I'm going to emit one deposit event. So deposit I'm going to call here, and from will be nothing but message dot sender. That means whosoever has called this payable function. Amount will be amount, reason will be reason, and timestamp will be block dot timestamp. Block dot timestamp. Perfect, done. So that's how your function for deposit looks like, right? We have done everything, right? So what is the issue here? Okay, perfect. So this is my deposit function. Similarly, let's write down the withdraw function. So withdraw function is also going to take some amount. So uint amount, and it is going to take the reason for withdrawing. So string memory reason, and then this function will be public, not payable, because you are not adding some money in this function. So public. Then requirement will be um, requirement should be, what we can do is so guys, the requirement here is the balance of the user should be greater than 0, of course, right? Otherwise you cannot greater than amount, greater than or equal to amount, otherwise you cannot withdraw that amount. So for that we are going to create one mapping, right? One map you can consider, one mapping you can consider, right? This mapping will be mapping, like the key will be address and the value will be nothing but the amount that I hold, the balance, right? And this we are going to call it as public balances, right? This is going to contain my balance also, right? So in the deposit also, whenever I deposit some money, I have to update my own balance, right? So once you have deposited, you are going to here say balances at message.sender, that means me, right? My address. You have to update the balance, or you have to add the got amount into the balance. So plus is equal to amount, right? Similarly, in the withdraw, you have to check the requirement whether the balances at message.sender should be greater than and equal to the amount, should be greater than equal to the amount. Then you can withdraw. Otherwise, you have to send a error, that means insufficient balance, insufficient balance. So like a expense manager, it is also like a bank, right? Your personal bank where you're adding some money, you're removing some money, right? So that is something that we're building here, right? So insufficient balance, right? Now after this, I'm going to update my balance if the requirement is satisfied. Balances at message.sender minus equal to the amount. That means it is going to decrease that amount from my balance. And after that, I'm going to add a transaction. So transactions dot push, right? Transaction, and in the transaction you have to define the address, whosoever is making the withdraw. So I'm making the withdraw, so message.sender, right? The amount, the reason, and the time. And after that, you have to say payable message.sender transfer the amount. So this is going to make this amount as payable. That means now this amount is payable to someone else, right? So amount. And the last thing will be emitting the withdraw event. So emit withdraw message.sender amount, the reason, and the timestamp. So block.timestamp. Perfect, guys. This becomes your withdraw function. This becomes your deposit function. Okay. Now we have to write the get balance function, right? The get balance function. So in the get balance function, you just have to define the address of the account. So address of the account, right? And you have to say this function will again be public because anyone can see my balance. So public view returns. So view we define whenever this function is just getting some data, not adding some data or updating some data. So that's where we define the view as the keyword. Returns, this is going to return the integer, uint integer. So uint integer because this is returning the balance. And inside the function body, I'm just going to say return balances at message.sender, or not messages.sender, you can say account, because the account address that we want to account balance that we want to fetch, right? So this is that balance function. I hope this makes sense to you. Okay, now let's write down the next function, that is get transactions count, right? So for get transactions count, it's a simple function, right? We just have to check the count of the transactions. So let's write down the simple function, that is this is again going to be public function, public view returns, and this is again going to return the uint variable. So uint, and this is going to return the transactions.length, like how many transactions I've done, these many transactions I have done. Okay, perfect. Next function, get transaction, like one transaction if you want to fetch. So uint, you have to define the index of the transaction, right? And this is again going to be public, again view, because you're not modifying any data. So returns, then you have to define the address, like you are going to get the address, sorry, not give the address. You will be getting the address. You are going to get the amount for which that transaction was there, and then you're going to get the reason, so string, and then you're going to get the timestamp. So timestamp is again going to be in uint, and this will be memory because you are just storing it for some time, and then uint the timestamp. Okay, and here you have to write down, first of all there will be one requirement, right? So require index should be less than the transactions.length, otherwise list, like the index is out of the list scope, right? So index should be less than transactions.length, right? Otherwise you can throw the error index out of bounds, index out of, simple thing, right? Index out of bounds, put a semicolon, and then you can say transaction memory transaction is equal to transactions at the index, and then you can return this transaction, return transaction dot the address, that means the user, then transaction dot the amount, the transaction dot the reason, and then transaction dot timestamp, this is what was expected. You see, we were going to return the address, uint, string, and uint. So user is address, amount is uint, reason is string, and timestamp is uint. Perfect. So this is my get transaction function. Now we have to write down the function for getting all the transactions, and in Solidity you cannot return a list from the function, right? That's why we have to iterate and return the things one by one. Okay, so this get all transaction is going to be public function, and it is going to again return some data. So public view returns, and this is going to return the list of the addresses. It is going to return the list of yeah, this will be memory now because we just going to store it for some time, memory. And then you are going to have the uint list memory, because this will store the amounts. So list of addresses, list of amounts, list of reasons, and list of timestamps. That's what I'm saying here, right? Okay, memory. Then you are going to store or return the string list memory, and then finally uint memory, list memory. Okay, because you cannot return a big list from the Solidity function. That's why we are doing this crazy task. Okay, so addresses list, address list is going to be memory users is equal to new address list, and then we are going to extract all the addresses from the transaction, and this address list should be of how much length, transaction.length, because from every transaction we are going to fetch the address and we are going to make this address list. So like this. Similarly, we are going to have the list of uint for the balances. So this will be uint, and this will be the amounts, not balances, amounts I meant. Okay, so this will be uint, and this will again be of length, transaction.length. This string, this will become string because these are all reasons. So reasons is equal to new string, and the final will be uint, which will be a list of timestamps. So timestamps. right? This is I timestamps, and this will again be event. Okay, so these are my 4 variables which are going to store the individual list. Okay, now I have to run a for loop. So for event I equal to 0, I less than transactions.length, simple for loop. Okay, no rocket science. I plus plus, and users at I will become transactions at I dot user. Transactions at I dot user. Okay, then amounts at I will become transactions dot I dot amount. Transactions at I dot amount. Amount, yeah. Okay, then reasons at I will become transactions at I dot reason. Okay, and the timestamps at I will become transactions at I dot timestamp. Okay, and now we can return the individual list. So return users, amounts, the reasons, and the timestamps. Okay, this is your get all transactions function. I hope I'm clear. Okay, now the last function that we have to write down is for changing the user, right? Let's say I'm dead and I want to transfer this account to my parents, then I have to change the owner, right? So this owner is going to take the address of the new owner. So new owner, right? And this will be a public function, and this can only be done once, right? So public, and this can only be called once, so only once. Owner is going to be new owner. That's it. Owner is something that I had defined here, right? New owner will be, the owner will be reassigned to the new owner. Okay, only owner, sorry, not only once. This is only owner. That means only owner can call this function. I mispronounced it only once. So it is only owner. That means only owner of this smart contract can call this function. Okay, so this is what our smart contract looks like, right? And I think we are done. I think we are done. I think this is some import issue that are not found or not unique. Only owner public. Only, I think it's not able to recognize, but yeah, it is there, right? So let's not worry about it for now. So owner is new owner. So this is my smart contract. I hope you have understood this whole smart contract thing, like how it works, what it does. It's just like a normal, a contract that we are writing, that these are the functions, these are the addresses, these are the amounts, something like that, and these are the functions that can be executed, right? So this is a smart contract which is written using Solidity programming language. In the next function, let's try to migrate this smart contract, or let's try to convert this smart contract into something that can be consumed by our Flutter client. Let's do that. Now let's define this only owner function. So basically, when we want to allow this function to be called from one single person or one single entity, that is the owner, we can define it using modifiers. So modifiers are nothing but they are also like functions, but they can be implied on another function. So let me just show it to you. Modifier, right? Modifier only owner, right? And this is like a normal function, right? And you can say require. So similarly, like here also you could have required this thing, like the the sender of the message.sender who is calling this function should be the owner. So but you can separate them out so that you can use this thing again and again and again. So here I'm saying require message.sender equal to owner. Otherwise you can throw an error saying only owner can call this, only owner can execute this, right? This is your modifier. Now you can cut this modifier and paste it a little bit up, so that whenever you need this modifier you can utilize this modifier. Right now you see this error is also gone. Perfect. So that's how modifiers work in Solidity. Okay, so there is some issue. Only owner, yeah, and after this you also have to define something like this, like closing statement or something, right? Okay, so that's how the only owner modifier is going to work. Okay, now let's start working on basically compiling this smart contract or deploying this smart contract through Ganache. Let's do that. Now it's the time when we have to compile this smart contract, right? Now we have written this whole piece of code, and you know that once we write the code, we have to compile it so that the machine understands it, right? Now it is the time when we have to compile this code, right? Or compile this smart contract. And for compiling and testing, we are going to need, not for compiling, but for testing the smart contract, we are going to need Ganache. And if you remember that I downloaded Ganache in the starting part of this video. And before we start working with Ganache, if you have just started to watch this video and you missed the previous part, let me tell you that I already have another course which is for full stack mobile app development, that is going to include Flutter, and we are going to make the backend in Node.js, Express.js, and TypeScript. So if you are one of those guys who wanted to learn full stack mobile app development with Flutter and Node Express, this course is for you. The best part is that I offer a community where if you have any doubt, you can directly, don't have to wait for anyone, just put a question here, and there are more than 100 people here who are going to help you out. And if not anyone else, I'm going to help you out, right? And plus we have live doubt session also. Okay, now we have to start working with the Ganache. So I've already installed Ganache, so let me just double click it, and I've already installed it, so let me just hit Ganache, and it is going to open the Ganache interface. So it is verifying, and let's open it up. Yeah, it is there, right? So this is Ganache, right? This is what Ganache looks like, and I can click on continue, and I can say quick start, right? And there I'm going to get all the accounts. So you see, these are all the accounts. These are dummy addresses, dummy wallet addresses, and here I get all the balances, right? 100 Ethereums I'm getting. Now you can also get the private keys, right? So for you, what is the important part? For you, this RPC server URL. Okay, I think it is not visible. Let me show to you. Yes, I think now it will be visible to you, right? You see this RPC server. This is something that you have to code in your truffle.config file. So go to VS Code and open this file explorer, and the last file you see, truffleconfig.js. Here we have to enable, or what we can say, we have to define our configuration for the truffle. So what I'm going to do is just remove everything, and we can start writing from the scratch, right? So first of all, we are going to write module.exports, and even if you don't write on your own, that is fine. You can directly copy this file which I am writing down, right? So module.exports, you have to define your networks. So basically you have to define on which network you want to test your smart contract, or on which network you want to run your smart contract, right? So network we are going to get from here. This is the network URL, right? So we are going to get from here networks, and then you have to define your development network, right? So development network, and for this I'm going to say you have to define your host, right? So your host is going to be 127 .0.0.1, which I'm taking from here, right? This is my host, and this last 7545 is my port, right? So this is my host, and my port is going to be 7545, and my network ID, network ID is going to be star. Okay, so just define it as a star. Okay, so this is how your network looks like. So come out of this network now and define the contracts directory. Like, where is your contract even located, right? How will the compiler know? So you have to define your contracts directory, and in this contracts directory you have to define the location of your contracts directory, which is nothing but this one. So you can say that dot slash, that means come out of this and go inside the contracts folder. Okay, so this is done. Now you have to define your compilers. So compilers, and in the compilers, your compiler is going to be Solidity compiler. So Sol C, that is Solidity compiler. So the Solidity Sol C, right? And the Solidity compiler is going to have some optimizer. So optimizer, right? And this optimizer is going to be enabled, like it will be enabled. So enabled. So I'm not remembering all of this. Okay, so don't worry that this you have to remember. No, you can just copy my file also. You don't have to worry about it, right? Enabled is true and runs is 200. Okay, so this is how this file looks like. And at the end you are going to have your db will be false, like enabled will be false. Okay, so this is some configuration file. You don't have to like remember whole of this thing. You can just copy once you have written it, right? So this is how your configuration file looks like. Now I have told my truffle that my network my Ethereum network is this URL, which is your RPC URL, and this is my port number, right? And this is how my Ganache, my private blockchain, looks like. Okay, so what we have to do now here is yeah, so now once this is connected to the Ganache, then we are going to utilize these wallet addresses to make the transaction. Like we will transfer this 100 Ethereum from 100 Ethereum, will transfer 10 Ethereum to this account, then we will deposit, then we'll withdraw, then get the transactions. All everything that we have coded, we can try on our Ganache network, right? Okay, perfect, guys. Now this thing is done, configuration thing is done. Now what we can do is you can just save this thing and go to your terminal and run truffle compile. Okay, so let me again okay, I think now it will be visible to you, the last thing. Yes, truffle compile. So we have to run truffle compile. So over here, sorry, control C, just say truffle compile. So once it gets compiled successfully, so it has failed. Let's see what is the issue. Let's try to debug together. So it is saying compilation warnings. Okay, let's remove that. Project contracts, working warning source. This is okay. Project syntax error. No visibility specified. Did you intend to add public constructor? Relevant source part starts here and spans across multiple lines. Okay. Expense and solidity syntax. No visibility and for public. Withdraw function. We have not defined the visibility. Let's define that. So let's go to our contract. Expense manager contract, and let's define, okay, we have defined actually. Let's save this. Is it saved or not? Now I've saved it, so command s, and now let's try to run the same command again, truffle compile. Again it is failing. Okay, not an issue. Let's see what is the issue now. So you see now only one issue. That means saving was the issue. I have not saved my smart contract. Okay, so yeah, now I have saved it. Compiling your contract, compiling slash contract expense manager contract dot sol project. This is the contract location. Parser error, expected primary expression, payable message dot sender dot transfer the amount. Okay, let's see what is the issue. So the issue is coming in line 54. So here, payable message dot sender dot transfer the amount. This looks good to me. What can be the issue? Checking it up. Payable. I don't want to like cut this part because I want to show you how to actually debug things. So this looks good to me. Okay, withdraw transactions. I have pushed one transaction to the transaction list. Then I'm making this as payable message dot sender dot transfer the amount. Yes, this looks good to me. I don't see any issue here. Expected primary expression. Let's comment this line for now and let's try to compile it like that without this. Let's see. Yeah, let's try to compile it without that. Compilation failed. Again, some more issues there. So compilation warning encountered, required compiler version. Source file does not specify the required compiler version specified. Okay, so one more thing that I forgot is to define the Solidity version. So we define the Solidity version like this, that like pragma solidity, and then you have to define for which Solidity version you want to support the smart contract. So you can just say that exponent sign, and then let's say 0.8.0 I want to support 8.0, or you can also check for the latest Solidity versions which are running, and then you can also define that version here, right? So basically I can just go on the internet and search for Solidity versions. So Solidity versions releases, and you can see that these are some of the versions that are out there. So the version which I have defined, that is also fine. Okay, now let's save it and let's again try to compile it. Truffle node. Okay, not an issue. Let's try to see. Sol C, Truffle is currently using Solidity compiler 0.5.16. Okay, not an issue. Let's define this version here. Okay, let's save it and let's try to compile it. Compilation failed. Okay, no visibility specified. Did you mean to use public constructor? and what is it saying? Source file requires different compiler version. Current compiler is point okay, node nightly. Okay. I'm just thinking which version should suit this. Point 20. Yeah, this is okay. And now if I just try to compile it, now the issue is like, the Solidity compiler versions are not matching for Truffle and the actual Solidity which is installed. So source compiler require different compiler version, and nightly builds are okay. Truffle is currently using this Solidity compiler, but one of okay, please update your Truffle config. Okay, so Truffle config, if I just go here, so in my truffle config.js, after this solc compiler, you see compiler solc, here I can define the version of my Solidity compiler which I want to keep, that is 0.8.19. Now I can save this file. I can go to my contracts file. You can see here also the same version is there. I can save this file, and now I can truffle compile. Now you see it is fetching, and you see compiled successfully. Now one more thing what I'll do is if I go to, yeah, everything looks good to me, but now I have to uncomment that line also, right? I have to uncomment this. Now let me just save it, and now again compile it, compiling, and now it is compiled successfully. Okay, so this looks good. Artifacts return to users action on desktop Flutter expense manager dapp slash build slash contracts. So if you go to this build, you see the contracts, and here you see the JSON file, right? So this is your whole information. Like this is the part which can be which can communicate with the Flutter, right? This is something that is very important, right? So this is the build of my contract. Like if we code a Flutter app, you get a APK, that is a build for your Android. You get a IPA, that is a build for your iOS. Similarly, when we build the contract, you get this JSON file, right? This is important. Okay, great. Now we have compiled our smart contract. That means we are ready to start with the Flutter thing, right? So let's do that. And before that, if something is required for Ganesh, let's do that also. Okay, let's do that. So now we have to deploy the smart contracts. Okay, so for that you need to come inside the migrations folder, and you have to create two files. One will be a global file which will define all your migrations, and second file will be the migration file for our smart contract, right? So go inside migrations and create your first file. That is going to like the file name is going to be let's call it initial migration .js file, and second file is going to be our expense manager contract migration.js. So these are the two files. So first of all, in the initial migration file, we have to define that constant migrations is equal to artifacts dot require, and the name will be migrations. Okay, then you have to say module dot exports, and you have to deploy all your migrations. Okay, so module dot exports. So basically I'm exporting this function which is my deployer function. Okay, so it is going to take a deployer, and it is going to deploy. So deployer dot deploy migrations. So all the migrations which are there in the migrations folder, they will get deployed. So let's save this and go inside your expense manager contract migration.js, and define your migration for this contract. So constant expense manager contract migration, or just contract, is equal to artifacts dot require your this thing expense manager contract. So basically this name is going to come from here, this one, expense manager contract, right? Expense manager contract. So try to name it in the same way. Okay, Now next thing will be exports module.exports, and I'm going to export a function. So export a function, again deployer, and this is going to deploy. So deployer dot deploy my expense manager contract. That's it, guys. Done. Okay, so just save this thing, and now you can run truffle compile. So everything is up to date, there is nothing to compile. So what I'll do is I'll delete this build folder, right? Delete this build folder, and now again do truffle compile. Okay, compiled. Now you can see that our contract is compiled successfully. Now only one thing is remaining, that is we have to do the migrations. Okay, so we have written our migrations. Now let's initialize this code, or basically just call this code. Okay, so just say truffle migrate in your terminal. Done. Compiling your contracts, and you see network up to date, and we have not got any issue. That means our contracts are migrated also successfully. Okay, so our contract is basically running on this private blockchain. So once you see this, that network is up to date, or you do not see any error, that means your code is working perfectly. Your smart contract is now successfully migrated and compiled. For that, you may also get some issue if your Ganache is not open. If you just shut it off or shut it down or close it, then you're going to get one issue. So always keep the Ganache open whenever you're working, or whenever you want to run your smart contracts, right? So you have to keep the Ganache open. Okay, so now our truffle work is done, our smart contract work is done, and now we have to start working with our Flutter projects. So let's do that. So now let's start and do the Flutter part. Now we have to start building the mobile app, right? Where I can call the deposit function, withdraw function, see my transaction, see my balance and all. Okay. So now you can see that my app is running in the iOS emulator, and in the lib, I don't have anything much. I just have the main.dart file. Now, if you are coming from my course where for the course of Flutter plus Node.js, there also I taught you how to structure your app properly. Again, I'm going to teach you here. Don't worry. So in the lib folder, just create your feature folder. Like the first feature that I'm going to create right now is going to be the dashboard feature, where I can see my balance and I can see my transactions. Okay, so this lib is going to have the dashboard feature, right? And now we are going to create the block inside it. So if you are unaware of block and you don't know anything, you can directly go on my channel. Again, I have covered it in the course, but don't worry about it. And you can directly go on my channel, go on the playlist, and you will find one Flutter block playlist. You see this Flutter block playlist? All of these videos are going to make you a master of Flutter block. Apart from these videos, you don't need anything else. Okay, so these videos are more than enough. Okay, so again, I'll try to cover some basic part of the block in this video itself, but for a very detailed study, just follow this playlist, right? It is one of the best playlists for Flutter block. Okay, perfect. Now in this dashboard block, first of all, I'm going to go in pubspec.yml, and in the pubspec.yml, I'm going to add the Flutter block dependency. So we can directly go on the internet and search Flutter block pub. So you see, this is the these two are the dependencies. So now let's go and add these two dependencies over here. Go inside, yeah, dependencies, and just define block, and just define Flutter block. Okay, save it, and it is going to save your dependencies. So something is wrong. Flutter block, any dependence could not exist. Yeah, so it is underscore. Now let's just save it. So now we have imported the dependencies. Now what we can do is we have to create the UI files, right? So inside this dashboard folder, just go inside and create a UI folder. And now inside the dashboard, you also need to create a block, because we are going to use block state management. So just hit Command Shift P and say new block, and you have to choose the location where you want to create a block. And first of all, you have to name this block. So I'm going to name it as dashboard block, right? Dashboard. And then it is going to ask you the location. So location is going to be inside my Flutter Expense Manager Dapp. Then go inside lib, then go inside the dashboard. And here I want to put my block. So now you see the block is created here. So in the block, what you have to do is, everyone knows, otherwise you can watch that video I'm just recommending, that where I've covered the theory, Flutter block theory, where I've taught about the theoretical part of block, like how block works, what is block, what is event, what is state, and all that. Right, I'll attach that video link also in the description. Okay, so first of all, in the event, because block needs an event so that it emits out a state, right? So in the event, I'm going to create one initial fetch event. That means whenever your app opens and dashboard page loads, then you want to load all your transactions and load your balance, right? So, or you have to connect to your Ethereum, the smart contract basically. Okay, so this class will be called dashboard initial fetch event, right? And it is going to extend dashboard event, right? And inside it, you can, for now, just don't define anything, just refine your block. So now create a block, like go inside your block file and just define your event here. So on this event, you first of all define the event, and then you have to handle that event, right? So you have to define one method handler, which is nothing but a function. Okay, so just define that handler here and just make it small d, that is the name of your function, and just click on this yellow bulb and say create a method. So it is going to create an empty function, which is basically my method handler for this event. Okay, now inside this event, I'm going to make the connection with the smart contract. Okay, so three cases, right? First case is going to be loading state. So class dashboard loading state. This will be loading state extends dashboard state. Next state will be error state. If something goes wrong and smart contract was not connected, then you have to show the error state. Otherwise, you have to show the success state. So this loading will become error and this loading will become success. Okay, so these three cases are going to be here. Now inside this block, whenever your event gets triggered, then you have to first of all emit the loading state. So emit dashboard loading state, and here I have to make the connection with the smart contract. Okay, so let's do that in the next module. Now before we make the connection, let's first sort out the UI part also. So in the UI, I'm going to create one dashboard page.dart. So dashboard page.dart file. Here create a stateful widget called dashboard. This will be called dashboard page, right? And let's close this. Yes. And over here, create a scaffold and create an app bar here. And app bar will contain the title of my app. So I'm going to name my app as Web3 Bank. So title text and name of my app is Web3 Bank, right? And then you have your body. So define a body, then a container. My container is going to have a margin, constant edge insets, dot symmetric, horizontal 16, vertical 16. Okay, now inside this container, so you can see the container now. Yes, you can see the container, right? Inside this container, I want to have a child will have a column will have a children will have first thing, which will be the balance, which will be visible at the top. So text, this will contain, let's say 0 point, not 0 point, I'm rich, let's say I'm rich, 10 ETH, that is your Ethereum. Let's call it 10 Ethereum, right? And style is text style, and define the font size as a bit bigger, so that, because this is the balance that I want to show this balance to the user. So let's say the balance font size is 50. Let's just save it. Right now you have to go inside your main.dart. So go inside main.dart, and over here in the main.dart, just clean everything up. The first thing that you have to do is your import material.dart. You have to define your main function, so void main, and over here do run app, and my app is my app, run app my app, and create a stateless widget here, which is nothing but my app, right? And over here create a material app, or return a material app, which is going to return your home. So home will be my dashboard page. Okay, save it, and you see Web3 bank, and I can see 10 Ethereums. So go to dashboard page, let's improve the design. And from the internet, let me also bring the Ethereum logo. So Ethereum logo SVG or PNG, SVG or PNG. And I see that, yeah, this one is okay. Let's just, let's first see if it is PNG. Yeah, this is PNG. So let's just save image, and let's save the image inside our project itself. So where is my project desktop? Okay, let's save it here. Let's save it here. And now let me take this up and put it first of all here. Now I have to create the assets folder, clean it up, and just close all. Yeah, remove this and create a assets folder. And inside this assets folder, let's put our image. So where our SVG went? Yeah, here is the SVG. Let's put it inside the assets, and let's rename it as ETH logo. Right now, go in your pubspec.yaml, and in your assets over here, just uncomment it, say it as assets, and import everything which is present inside your assets. Save it. Now we also need to work with SVGs, so let's import the Flutter SVG package, SVG, right? This is the Flutter SVG package. So let's just copy this, go to pubspec.yaml and paste it below it and save it. Okay, and over here we can see how to work with SVGs. SVG picture.asset. Let's just copy it, go inside our main dot, or go inside our dashboard page dot. So lib dashboard, dashboard page dot dart, and now this text is going to come inside a row. So wrap with a row, and main axis alignment is main axis alignment dot center, and font weight will be bold. Yes, and like on left hand side of it, I'm going to put the logo. So put the logo, right? Import SVG, Flutter SVG, and asset name is going to be assets slash ETH logo dot SVG, and put the comma, and put constant sized box. Width will be 20, not 20, let's say 12, and put comma and save. You see the logo is here. We can increase its height and width. So height, let's put it 50. Width, let's say put 50. Let's save it. Yes, looks good now. So this is my balance, which is hard coded for now, right? And now I can also improve the UI of this app bar. So background color, if we can just improve. So theme dot of secondary color or accent color. Dot accent color. Do we have accent color? Or context dot primary color? This is our primary color. Doesn't look good to me. So let's try to accent color. Secondary color is there. Secondary color is also. I think some of the changes have come in the Flutter 3 or the latest Flutter which I'm using. So that's why. So let's use our own colors. For now, I'm going to just hardcode, but it is recommended that you hardcode your colors in the utils. So let's do that. Let's do that. Let me teach you how to do the stuff right. So I'm going to create a utils folder, and also I'm going to create a features folder. And inside this features folder, I'm going to put my dashboard. Okay, yes, looks good. Features has dashboard, utils has colors.dart, and inside it class app colors, right? And this is going to be static constant color is equal to color 0xff, and let's bring the color from the internet, HTML color picker, HTML color picker, and let's use a bit light purplish. So let me go here. Yes, and let's take this color. Yeah, I don't want to like take pink, so let's go a bit in the bluish direction. Yes, this is good. So let's just copy it and let's just paste it right here. Put a semicolon, remove this hash and import. Okay, material.art is imported constant color. Yes, so it will be my accent color. So accent, let's call it accent. Yeah, this looks good. And now go to features, UI, dashboard, and here background color, put app colors dot accent. Let's refresh. Yes, looks good. Looks not very good, but I think it is okay. I think it is okay. Okay, this looks okay. Now below it, I'm going to have two buttons which says deposit and withdraw, right? And let's do that now. You know what? I have one better idea. So let's do one thing. The scaffold, let's give it the background color as app colors dot accent. And one thing I'm going to do is I'm going to make it more light. So let's make it a bit more light. Let's copy this and bring it to the accent. So let's remove it. Let's paste it. Let's remove the hash. Save it. Yes, 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 yes. And now you see what I'm going to do. Remove this file explorer. Now for this text and this whole row, I am going to wrap this row with a container. You see, wrap it with a container and gives this container some padding. Let's say constant edge insets dot symmetric, horizontal 12, vertical 8, and also give this a decoration box decoration. Color will be colors dot white, and then give a border radius will be border radius dot circle 12. Yes, and this row will have main axis size as minimum. And one more thing, this container you wrap it with a center. Perfect. So this is my balance now, right? I don't know like how it looks good or looks bad. I'm putting the UI task on you. I'm just going to teach you the logical part, okay? And whatever UI I can build without wasting more of your time, let's build that. And UI you can play with, right? UI you have to do. And yes, if you are watching this course till now and you have not dropped it, just take a screenshot till here and put it on LinkedIn that you are making this web3 bank application and tag me, and I'm going to give you some suggestions or give you some feedback. Okay, so let's do that and increase your LinkedIn network also. Okay, perfect. So this is how this thing looks. Now after this I'm going to have two buttons, basically deposit and withdraw. Okay, so let's do that. So come out of this center and put a row, and first of all put a size box showing the height as 12, and after that put a row again, row children, and have expanded and have two elevated buttons, elevated button, right, on press, and put child as text and say deposit. Okay, and let's design it a bit. Or what you can do, instead of like defining the elevated button, let's actually remove it. Okay, wait, yes, let's have the expanded and have a container itself. It's easier to decorate a container instead of a button. So let's put the height as 50, and decoration box decoration border radius will be 12. Save it and give it a color also. Give it a colors dot white, not colors dot white, because it's a deposit function. I'll make it colors dot green. Looks very bad. We have to bring one greenish lightish color also from here. Yes, this is okay. Let's copy this and let's go to our colors file, static, constant color green accent is equal to color 0xff, paste it, put a semicolon, and also spelling of static, and also you have to copy this, paste it again, and make it red accent for the withdraw button, right? And bring one red color. Yeah, this looks okay. Let's bring it and let's paste it here. Let's remove this hash thing. Let's remove this hash thing. Yeah, looks good. Okay, now go to dashboard page, app colors.green accent, app colors.green accent, and inside this I'm going to say child text plus deposit style, text style, color will be colors dot green, and I'm going to put it at the center. So this text will go in the center, so wrap with a center. Okay, and I'm going to make it bold a bit, so style, size 24, and font weight dot bold. Okay, and now similarly copy this expanded and put a constant sized box width 8 and paste that same expanded here and make the color as red and this color as red accent and this as withdraw. Okay, and one more thing, let's call it credit, and let's call it, this will be credit, sorry, this will be plus and this will be debit minus. What I'm doing, yeah, let's call it debit, and this is going to become red, this is going to become red accent, and this is going to become green, and this is going to become green accent. Okay, okay, looks good, credit and debit. Okay, now if I click on debit I want to withdraw, if I click on credit I want to add. Okay, now below it I want to have a transactions list, so let's do that now. Now let's create the UI for the transactions, and for transactions I have to first of all also create one model, right? The model which defines the one transaction, right? So go in lib and create a models folder, create a model called transaction model.dart. Okay, and over here create a class called transaction model, and over here my transaction, you already know what is inside my transaction. So final, you can just go in your contracts and you can see this is my transaction. You have your address, so final string address, then you have the amount, so final int amount, then you have your reason, so final string reason, and then so this will become al, yes, then you have your timestamp, so final date time timestamp. Okay, let's remove this, let's create a constructor, so generate a constructor, right? This is my constructor. Okay, and now based on this I can actually go in my dashboard UI dashboard page, and now I can define some of the transaction, like dummy transaction, real transaction will come from the Ethereum blockchain. Okay, so come out of this row and say constant sized box height 12, and now define expanded list view because transactions will be in a list, so expanded child list view, children let's have one transaction, one dummy transaction, container. Child will be row, yes, row, and inside this row I'll have children, and then I'll have, first of all, I'm going to have the amount. So text, this will be, so first of all, yeah, text will be amount. So let's say the amount is 1 Ethereum, so 1 ETH. You see this is visible here. And before that I'm going to have one text which will say transactions. Let's increase it font size, some weight, and let's add a comma, and also let's put the column cross axis alignment dot start. Okay, and this, let's make it 20, right? And now the container will have some decoration, border radius dot circular 12, and color will be colors dot white, right? And some padding, so container will have some padding, so padding constant edge insets dot symmetric from vertical 12, horizontal 12. Let's save it. And now this text will again have this Ethereum logo. So let's wrap it with a row. We already have a row, right? Yes. So let's put that svg picture dot asset. Asset is asset slash eth dash logo dot svg, and put the height as 24, put the width as 24, and remove this comma and put this, and now put some spacing between them. So constant sized box, width is 12. This is actually a bit large, so let's put 6. And now let's increase the size of this Ethereum. Text style, font size 20, font size 20, font weight dot bold, yes, and also put some spacing between this thing. So let's copy this and let's paste it here. Okay, yes. And now let's decrease it a bit. Yes. And now let's put the address. So the address is going to come below it. So this is a row. Let's wrap this row with a column. Copy this text, and below this row paste it. And the address of your wallet, something, it looks like this. This is the address. So let's just copy it, paste it. Okay, and the font size will be a bit small, 12. Correct. So this is the address of the wallet from where the transaction is made or to the transaction is made, right? And now after that I can have reason, like the reason for which this transaction was done. So reason can be, let's say, nft purchase, right? And the font size can actually be 16 here, and we can put the column, and we can have cross axis alignment start. Okay, so this is my one transaction. You can also have the time that I'm like just counting on you. You can put the time, and this is how my transactions actually look. Right now I have to have a page for deposit and one page for withdraw. Okay, one page for deposit and one page for withdraw. So this is okay, right? This is okay, looks good. Now let's have features, one feature for deposit and one feature for withdraw. Okay, yes. Now let's just close it and see what we get. Features, 3 features. Yes, deposit will have a UI file. So let's create a new file called deposit.dart, deposit.dart, and withdraw.dart. So withdraw.dart. Okay, let's code these files. So now let's try to write down the withdraw file and deposit file. So deposit file, stateful widget, deposit page, right? And over here, let's go on the dashboard. And when I click on debit, let's navigate to the withdraw page. And when I click on credit, let's navigate to the deposit page. So go to dashboard page, and over here on this, you see this expanded, just wrap it with an inkwell. Wrap this container with an inkwell. On tap, navigator dot push material page route context, and I have to navigate to the deposit page. Similarly, let's create the withdraw page. And let's navigate here. Yes, it is navigating. Let's create these pages. So deposit page is going to be green. So background color will be app colors dot green accent. Let's create a body. Margin everywhere 16. Child column. Children. Constant sized box. From top, let's give it height 80. Sorry, yeah, 80. And then I'm going to have some text fields, which will be for entering the amount, entering the reason, and entering the address. Okay, so yeah, let's create it. So text field, decoration, input decoration. I'm not going to decorate it more because it will waste your time and my time also. So decoration and all, everything I'm putting on you. I'll just enter the hint text, enter the address, right? Let's just save it. Now let's click on credit and I can see the address here, right? Now text field, let's copy the text field and paste it again and again. So next text field is going to be enter the amount, and the last text field will be for entering the reason. Okay, let's have one big text here after the sized box. Deposit details, style, text style, font size will be 32, font weight dot bold, and after that have some sized box, height of let's say 20, and let's have cross axis alignment dot start. Okay, looks good. Okay, looks okay. I won't say good, but yeah, it is okay. And after that, I'm going to copy the same sized box, paste it here, and then have a simple elevated button. Not a button, let's have a container. And let's copy the container from here, the deposit container. Paste it here. Okay, let's make it withdraw. Sorry, yeah, deposit. And this will be plus, this will be green, and this will be green accent. This won't be visible, so what I'll do is I'll mark this also as colors.green, and this one will become colors.white. Okay, okay guys, this looks okay. Okay, now when I click on it, I want it to communicate with the smart contract, call the smart contract function and deposit the money into my account. Okay, now let's just copy, not the whole thing. Yeah, first of all, we also need to have text editing controllers. So final text editing controller, this will be for address controller. Address controller is equal to text editing controller, and two more text editing controllers, right? This one will be for the amount and this one will be for the reason. Let's give this controllers to our text fields. Controller will be my address controller. This controller will be amount controller, and the last controller will be the reason controller. Save it. And now let's just copy everything inside this class. Go to withdraw page and paste it right here. Okay, this will become withdraw, this will become minus, this will become red, and this is going to become red accent. Red accent. Okay, looks good. Now we can go back, click on debit, yes, click on credit, yes. So this debit should be withdraw details, withdraw details. Okay, yeah, looks good man, looks good. So we have an app where you can see your balance, you can debit some money and you can credit some money. Okay, and you are going to see your transactions. Nice app, nice app. I won't say it's a useless app. Okay, it's a nice app. Okay, good. So now we have to start working with the smart contract. So now the logical part comes. This was all UI things, right? Anyone can code it. Now the hard part where we have to communicate with the smart contract. Let's do that. So let's go to our block, right? Now step by step we are going to do things, okay? And all the steps I'm going to write it in the block file, dashboard block. So first of all, we know that we are going to, whenever this dashboard page loads, I'm going to call the call this event, right? I'm going to hit this event or add this event. So in this event, first of all, I have to make the connection with my blockchain. Then I have to fetch my get the ABI. So first of all, I have to make the connection with the blockchain. Then I have to get the deployed contract. Then I have to get the ABI, and then I can fetch all my previous transactions or my transactions. This is what is expected. Okay. So as soon as the loading state is emitted, I can start doing my work. So for doing the work, first of all, what you need to do is over here, I'm going to define the list of transactions. So list of transaction model, which I'm going to get from the smart contract, right? Transaction model, transactions. And as soon as I get the transactions there, from there, I'm going to update this variable, right? And this variable will be used to show the transactions in the app. So this is the variable, which is now initialized as the empty list. Now I need the RPC URL. Okay, so I need the RPC URLs. Final string RPC URL. This RPC URL is nothing but where my Ganache is running. So Ganache is running on this HTTP endpoint on this port. So let's copy that, paste it here. Okay, and this HTTP, let's make it small. HTTP. Okay, and it's running on port 7545. So this is my RPC URL. Now after that, I am going to have the private key, right? So private key of the address. So now we need the private key. So basically it is not recommended that you code or hard code your private keys in your app. So basically you can use something called Wallet Connect with your MetaMask. So this we can see later when we are diving deeper into more advanced blockchain projects. So this is a third-party service which you can use to connect your wallet like MetaMask with your apps, right? But for now we are just working for this tutorial. So let's hard code the private key. So final string private key. is equal to, and let's bring the private key from the Ganesh. Let's say we are going to work with this address, this wallet. So for the private key, just click on this key, and here is your private key. Okay, so let's paste that private key over here. Okay, and let's click on done. So this is done, right? Next thing that we are going to need is we need the web3 Dart library basically. So let's go here. Copy this, go to pubspec.yaml and paste it and hit save. So let it download. So this library or this package is basically going to help us to communicate with a smart contract. Okay, now what we have to do is, now we can go on in our block file, and we can make a web3 client. Okay, so web3 client we are going to need. So let's define one web3 client here. So web3 client, web3 client. Let's initialize it as like null initially, and after that, once I have defined my private key, I'm going to say that my web3 client is equal to a web3 client URL. URL is basically going to be my RPC URL. RPC, what is it? Okay, this one it is. RPC URL and your HTTP client. So HTTP client, for that again we need the HTTP package. So let's go in the pubspec.yaml and define HTTP, save it. Okay, so now we can go back, and also we need to make a socket connection. So we can just directly copy this, paste it, and just you need to do one thing. So just say socket URL, and you just need to change HTTP to WS. That is your web socket. Okay, nothing else. Now you need to define your HTTP client. So HTTP client will be your HTTP. So I have to import HTTP first. So let's import HTTP .dart as HTTP. Okay, now HTTP dot client. So this is my HTTP client, right? And after that, you can define your socket connector, right? So define this, and then you have your socket connector. So in this socket connector, you have to just define one simple function, which is going to return IO WebSocket channel.connect. So basically I have to import the socket thing. So for that, I'm going to have one package, right? So that package is going to be, let me search on the internet, what is the name of the package? So the package name is WebSocket. Okay, so I'm working on the second monitor. Let me bring it here. WebSocket Flutter. So basically it is called WebSocket channel. Yeah, here is the package. So let's just copy it and go to our pubspec.yaml and paste it below HTTP. Okay, yeah, this is done. Great, guys. So now what you have to do is you have to define your WebSocket channel here. So over here, define IO, that is input output, WebSocket channel, and over here WebSocket channel.connect, and here the WebSocket URL you can define. So socket URL, and then you can say cast to string. So cast to string. Perfect, guys, perfect. Put a semicolon and you are done. Okay, now this is not like done, but yeah, one thing is done, that now we have our web3 client. Using this web3 client, we can communicate with our smart contract. Okay, now after this, three more things we need. Okay, you need your ABI. Okay, that is application binary interface, right? That's basically the JSON or the build of our smart contract, which is contract. Yeah, this we need. Okay, this I'm talking about, this we need. Okay, so let's go in the dashboard block, get ABI. So how to get your ABI? So basically for getting your ABI, you need to define first of all your ABI file, which is a string. So string ABI file is equal to await. You going to use root bundle through which you can import any string, right, from your assets. So load string, and string location is basically present at build slash contracts slash the name of your contract, which is expense manager contract. So let's just copy it, paste it here, dot json. Okay, so this is my ABI file, and we need to write async here. Okay, so this is my ABI file. Now you need to convert this ABI file to like you have to JSON and decode it. Okay, so you can say var JSON decoded is equal to JSON decode, and this will be your ABI file. Okay, now you have your JSON decoded ABI. Okay, now you need to get your ABI code. Okay, so you can say ABI code is equal to, and basically you have to define your ABI code. So that I'm going to define over here, let's say, and this will be late. So you need to define it over here. So late contract ABI code for every smart contract. Whether you build any hi-fi smart contract application to connect it with your front-end app, that is your Flutter, you have to do the same steps. Okay, ABI code is equal to contract ABI dot from JSON. Contract ABI dot from JSON. The JSON data is JSON decoded. JSON basically now this needs a JSON, so JSON encode, and this will become JSON ABI. Basically JSON decoded, so JSON decoded at ABI. Okay, so if I go here, you see in my JSON I have this ABI. Okay, so this part I'm trying to access in my dashboard block over here. JSON decoded at ABI, convert this into a JSON like this. Okay, and then you have to write down the name of your contract. So copy it, paste it, put the semicolon. Okay, now you need your contract address. Okay, so contract address. So again I have to define one more variable at the top, which is again late, because this is again going to be initialized in the future. This will be Ethereum address, and you can call it as contract address. Now we have to get the contract address, so let's get that. So for the contract address, what I'm going to do is basically how we can get it. Yeah, so here I've defined the variable contract address, right? So contract address is equal to Ethereum address dot from hex, and hex is going to be my JSON ABI, not JSON ABI, it will be JSON decoded actually. So JSON decoded at networks at which network? 5777. From where it is coming? It is coming from here. You see, network ID 5777. Okay, so 5777 at address. Okay, so this is your contract address. Now you need your credentials. So over here you see that I've also defined one Ethereum private key credentials, and now you have to reinitialize it. So creds is equal to Ethereum private key dot from hex private key. Okay, perfect guys. So that's how you get your ABI, or we can say get your credentials, right? Now you need to get your deployed contract. So / get deployed contract. So now we have to get our deploy, spelling contract. So in this I am going to have variables of all my functions, right? So my functions are going to be, so I can have again comments and say functions. So contract functions, so again they will be late, right? So contract functions, contract function, right? First contract function is going to be deposit function. Deposit function. Next contract function is going to be withdraw function. Withdraw function. So next will be the late smart contract function, withdraw. So late contract function for withdraw, right? And next contract function for get balance, right? And next contract function for get all transactions. Okay, great, looks good. And after that, what I'm going to do is get deployed contract. This will be deployed contract. So again, we have to define this also as a variable. So before that itself, late deployed contract, right? And now you have to say deployed contract is equal to deployed contract ABI code you have to provide. So your ABI code and the address is your contract address. Okay, right? And now you have to initialize your functions. So one was deposit function is equal to deployed contract dot function dot functions. This will be name. You have to put exactly as you see in your contracts, right? So this, okay, paste it right here and put the semicolon. And now do the same thing for 3 more times. That will be for withdraw, where that will be for get balance, and this will be for get transactions. Okay, and let's take out the function names. So withdraw, copy it, paste it right here. Next is get balance, copy it, paste it right here. And last one is your get transactions, get all transactions, copy it and paste it right here. Okay, so that's how this is done. And now I'm going to call the function for fetching my transactions, right? Fetching my transactions. So let's do that. And so basically fetching the transactions, right? So what we can do is, so we have transaction models, right? So let's do that. Await web3 client dot call. That means I'm going to call a function. Contract is your deployed contract. Contract is my deployed contract. Function is your which function? Get all transaction function. Get all transactions function. Parameters nothing. I don't have to pass anything, right? So that's how your web3 client dot call works, right? So that's how it works, and it is going to fetch all your transactions. And let's try to see what we get. So final data is equal to this, and let's try to log this data. So log this data dot to string. Let's see what we get. Okay, I think this is good. Okay, it's becoming a long tutorial, but yeah, it is actually a fun tutorial. Okay, and yeah, let's do it, guys. First of all, I'm going to put everything inside it. Everything inside this whole thing is going to go inside try catch. So let's paste it here, and inside the catch I'm going to log the error dot to string. Let's save it, and let's go to dashboard page, and in the init state, let's say dashboard. Okay, I have to create an instance of my dashboard block. So final dashboard block is equal to dashboard block, and over here say dashboard block dot add dashboard initial fetch event, and we are ready to run the app. Let's show your console, and we can refresh. Now let's see if we get any issues. Unable to load asset build slash contract slash expense manager contract.json. Asset does not exist or has an empty data. So one thing that I have to do is in the pubspec.yml, I have to allow importing data from here. So this should actually be slash build slash build slash contracts slash contract slash yes. Let's save it. Let's refresh. No such method. Empty square bracket was called a null, receiver null. Tried calling at address. Okay, I think what we can do is we can actually define it like this. Let's consume this address. Okay, let's consume this address. So in the block, instead of depending on that thing, I can actually say this is my contract address. Okay, and let's try to refresh. Value not in range. 32. I got 32. Why? So before we move forward, I think one mistake we have been doing is if I just close everything up, you see in the migrations, if I go to not in lib migrations, we were not following the correct order. So this like the correct format of naming these files. So whenever you add one more migration, you have to rename these files like in the order. Like let's say if I want to do another migration, so that should come as 3 underscore like that. So that's a way of migrating. So I just found this on like I knew this, but I forgot to mention that when I was teaching you. So this is very important and you must follow it. Okay, so now let's try to run again truffle compile and truffle migrate, and let me remove this contracts folder from my build, and let's try to generate it once again. Okay, so I've now renamed my files, and you see that in truffleconfig.js I'm having everything same, like nothing changed here. Okay, so now let's run truffle compile. Perfect, successfully compiled. And now truffle migrate, because we did not try this after connecting with the Ganache and then seeing if the balance is also reduced in my Ganache account. So truffle migrate. So let's hit this. Okay, everything is up to date. You see. So you can see some logs that something has happened, and you see that deploying migrations. This is my transaction hash. This is my contract address. This is important, right? We need this contract address. And if you get back to your, and this is my expense manager contract. So this is the second contract that we migrated. And for this is my contract address. And this is important. So if you go to your Ganache, you see that some balance is also reduced now, right? So this is important to observe, that this balance is now reduced because whenever you deploy a smart contract or run a function, some gas fees is going to be consumed, and this is the reduction that we can see here. Okay, now grab this contract address. Just grab this contract address, because we need this contract address, because through this contract address itself we can communicate with our function. So go to your dashboard block, lib features dashboard block, and over here at one place I had defined, yeah, this is my contract address. This is the contract address. Instead of just defining everything, we can just define it like this also, like this. And you cannot define it like a string, so you have to do is ethereum address dot from hex and your hex should be like this. Or what we can do is, instead of following this way, we can get back. Yeah, and over here I had forgot to define the contract name. Yeah, this is good. And dot from hex, yeah, perfect. So just remove this whole thing and paste your contract address right over here. Okay, now we are ready. We have defined our contract address, we have defined our credentials, we have defined all our functions, we have defined the get all transactions function, and we are trying to call this function over here, and we are going to logging the data, like what exactly we get from the transactions. We are trying to get that data. So now let's try to refresh the app. So we are getting empty. Okay, so I also logged my ABI. So over here you see I'm logging the JSON decoded format of my ABI. It's not required actually. Let's just save it. Okay, and let's just refresh. So you see I'm getting some empty data, so that is fine, right? Because there is no empty data. This is for you see like how I had returned my transactions. The first part is for the addresses, second part is for the amount, third part for the reasons, and fourth part was for the timestamp. So it is empty because there is no transaction in my transaction list in my smart contract. That's the reason. Now I have to work with this deposit function and this credit function. So let's do that now. Okay, so for deposit and credit, we're definitely going to need the events. So I'm going to create dashboard deposit event extends the dashboard event, right? And for this, I'm going to accept a transaction model, right? Transaction model, and let's create or let's generate a constructor, right? Similarly, I'm going to need the same thing, but that will be for transaction withdraw event. Sorry, dashboard withdraw event. Let's copy this. Let's paste it right over here. So this is again going to this is not, yeah, again, yeah, transaction model will be required. Perfect. So these two are the events. Let's just copy the first event, and let's create a method handler for that. So on this like this, and you can say dashboard d create a method. Okay, now go to event and create a withdraw event method handler. So go here and right over here on this event, just do or just call this method handler, right? So that's how you define your method handlers in block. Okay, okay, perfect. Now here we have to do nothing. We have to just call the smart contract functions like we did here. So I'm just going to go here and copy the same thing. Okay, so this again will be an async function, and this again is going to be an async function. Okay, perfect. And I'm going to call final data is equal to await web3 client.call. Contract is deployed contract. Function is going to be the deposit function, right? And parameters, yes, parameters is required here because deposit function is going to need four parameters, right? Not four parameters. Let's see how many parameters it needs. So go to contracts, expense manager contract. This is your deposit function, amount and reason. Only two things we need. Okay, amount and reason. बाकी like time वगैरह वो खुद देख लेगा, right? So time and all we don't need. Okay, so go here, and for the parameters we need the amount and the reason. So amount I'm going to get from event dot amount transaction model dot amount, and the reason, so event dot transaction model dot reason. Perfect. Save it. Perfect, guys. Now the same thing we have to do for withdraw function. So let's go here, save it, and for withdraw what I need is go to yes, and see the withdraw also needs the amount and the reason, nothing else it needs. Okay, so let's go in the dashboard block, and I'm going to need the same thing, amount and model, just the function is going to be changing from deposit to withdraw. Now here we are only dealing with one account, right? Because this is my personal bank account, right? I am not going to work with multiple accounts, right? So address and all we don't need to pass here. Okay, perfect. So that's why whatever I did here, the address, I'm going to put my own address itself. It is actually not required because my smart contract is automatically going to take the address from the smart contract or the deployed contract address, right? So this is actually not required, but let's keep it. Okay, perfect, guys. This is looking good now. Okay, so as soon as I get some data, I can actually, it is not going to give me some data obviously. So what I can do is I can log the data. So log the data dot to string. And one more thing that we need is so go over here and over here. One more thing that we need is balance. right? The balance. So over here, define uint balance, right? Integer balance. And whenever I'm calling the transactions, I also need to call my get balance thing. So final data, this will be transactions data. And after that, we can actually make it transactions data. Transactions, why it's not taking, okay, don't worry, let's put the next thing. And the next thing is going to be final balance of the user. So balance data is equal to web3 client deployed contract, and the function will be balance, get balance. Okay, and we can print this transactions data, plus we can also print our balance data. So balance data, mm, balance data. Perfect, guys. So as soon as I'm making a touch with my contract, I'm initializing my contract, I'm getting all the transactions, I'm getting my balance, right? I'm logging the transaction data and my balance data, and these two functions are for deposit and withdraw, nothing else. It's simple, super simple. Okay, what is the issue here? Yeah, so the int balance is going to be 0 initially, right? Okay, perfect. Now we are all set, and as soon as yeah, we are all set. So let's try to refresh it and see what we get in the log. So must match function parameters 0. So what is the issue? Must match function parameters 0. What is this? Where is the issue coming? Do we need some parameters for get balance? Let's try to see here. Get balance, yes, get balance needs the address. So what we can do is, over here we can provide it the address of our should we provide it here or there? mm, let's provide this one. Copy this, and this is the get balance, provide this address. Okay, let's refresh. String is not a subtype of Ethereum address of data. Dot to string we have done. So what is the issue coming? Ethereum address is not a subtype of type data. So I think the issue can be, yeah, over here. So this thing will actually be Ethereum address dot from hex, and this is my hex actually. So yeah, we are good to go now. Let's refresh. Yes, 0. We got 0. Perfect, guys. Perfect. This is working. So we can see that we are getting the empty transactions list, and we are getting the balance. Now let's try to emit the success state after this first initial event, so that we can update this data and this list data with the actual data that we are getting from the smart contract. So in the dashboard state, I'm going to have this dashboard success state, right? So this is going to return final list of transaction model, transaction model, and let's call it as transactions, right? And it is also going to return me the final int balance, right? These two things I need in my dashboard page.dart, right? So let's generate a constructor, right? And in the block, once I have done all of this, if I get the error, I'm going to definitely emit the error state, right? Dashboard error state. Okay, but if not, I'm going to return those two things. And for that, I also need to create the transaction list, right? So what I'm going to do is I'm going to say list of transaction model transactions, or let's call trans, is equal to empty list, and I'm going to iterate through the result of my the transaction data. So for int I equal to 0, I less than transactions data at 0, or what I can say, yeah, at 0 dot length, right? At 0 dot length, that means I'm going to iterate through this, right? First thing, I plus plus, and I'm going to create a transaction model. So model transaction model is equal to transaction model. The address is going to be transactions data at 0, because the first thing was for addresses, right? So copy this, paste it, and then paste I, because at ith index I will be filling up the address, right? Now let's copy the same thing, paste it for timestamp, paste it for reason, and paste it for the amount, right? But this 0 will change, right? For first thing it is 0, that is fine because the address. Second thing was for the amount, so 0 1, then 2 for the reason, and 3 for the timestamp. 3. Okay, looks good, perfect, it looks beautiful. The one thing, the problem that can create is this thing is actually not in date time. We are going to get this in integer format, right? So what we have to do is we have to say date time dot from microsecond since epoch and paste it. This is actually your date time. Rest of the things are okay. Okay, perfect. So this is your transaction model, and once you have created your transaction model, just add that trans dot add your transaction model. And once you have done this, you need to add it, or you need to reassign this value transaction is equal to trans. Okay, so let's do that. So transactions is equal to trans, and now it's time to do the balance. So balance will be integer, so int bal is equal to the balance data, which is coming out to be this, the balance data at 0, right, the first index. And the balance data, not the balance data, but actually your, do we have a yeah, this balance, perfect. So balance is equal to balance is equal to bal, perfect. After that you can emit your success state, so emit dashboard success state. Transaction will be transactions and balance will be balance. Okay, let's save it and go to your UI file dashboard page.dart and wrap it with the block consumer. This whole container will be wrapped up with the block consumer. So wrap it with the block consumer, import the block files, and this block is going to be nothing but dashboard block. So dashboard block state will be your dashboard state, and define your block value. So block will be your dashboard block. Okay, now builder is something important, so let's remove this whole return statement from here, and over here I'm going to have a switch case, because switch case is going to cover all my three states, that is your loading state, error state, and your success state. So case dashboard loading state, if the thing is currently still loading, then I'm going to return center your circular progress indicator. Next case is going to be for error state, dashboard error state. This case is going to return center child text error. Okay, then the last case, which is for case dashboard success state. Okay, dashboard success state, and this is going to actually return that whole container piece. Okay, right? Yes, looks good. And at the last, we don't need this break, and for the default case, just return the sized box. Okay, perfect. Right, this looks good. Let's refresh it. So something is going wrong. Big int IMPL is not a subtype of int. So this we need to convert. So from the smart contract, we don't actually get the integer format, right? We have to convert this into the integer. So from here, this part, which is your amount, and maybe this part also, which is again your integer for the timestamp, and this balance, getting returned in the form of big int, right? And we have to convert them into int. So let's just copy it and let's try to go on the internet, search for ChatGPT, and paste that here and say Flutter, so that it converts that into integer. So it is going to give me the code. So big integer big int dot from big integer dot to int. So I think dot to int, if we do, we are going to get the data. So let's do that. So dot to int, right? And maybe over here also dot to int, and over here also, because this is my balance dot to int. Let's just save it. Let's try to run it. Yeah, we got the data. See, we got the data. Perfect. Now go to dashboard page. This balance is not going to be hard coded, it is going to be the real data. So text will be success state, that is your state dot, or what we can do, we can create a new variable over here to store the dashboard success state. So final success state is equal to state as dashboard success state, right? Now you can access the data from success state dot balance dot to string plus add ethereum, eth. Okay, looks good. Constant, remove it. Let's just save it. So 0 ethereum. And over here for the list view, go to your list view, list view, yeah. So this will become list view dot builder now, right? And this is going to have the item count, which will be success state dot transactions dot length. Perfect. And it is going to have the item builder, context and index, context and your index, context and your index, and it is going to return the card, which is this card. So copy this whole container, cut it and remove it from the children and paste it right over here. Put the semicolon, save it, nothing, because why? Because there is no transaction till now. Okay, now let's try to debit and credit. That's the only thing that's pending in our app, right? So go to your debit page and your credit page, deposit page, and accept your block instance, right? So final dashboard block, right? Create a constructor. So generate a constructor, right? And over here, when I click on this deposit function or deposit button, I want to add a event. So wrap it with an equal, k will be small, and have an on tap on it, which will say dash widget dot dashboard block dot add dashboard deposit, because this is a deposit, so this will be, yeah, deposit event transaction model. So transaction model, the data address is going to be the address controller dot text, right? Amount is going to be the amount controller dot text, and this we have to convert into int. So int dot parse, again we have to convert into big int also, right? So reason will be reason controller dot text, and the timestamp is going to be, let's say, datetime dot now dot to dot microsecond sense epoch, okay? And what does this want? This wants in datetime dot now, so let's let it be like that and save it. And anyways, we are not going to pass datetime dot now to the smart contract, right? So this looks okay. Now let's pass this dashboard block to our dashboard page. Okay, let's just save it, and now let's try to refresh it once. Click on credit and deposit details. So enter the address. So let's copy the same address. Let's just copy it, and or to just see, yeah, that is fine. Let's just paste it, allow paste, and enter the amount. So let's say 1 ethereum. Enter the reason, let's say vegetables. Click on deposit. Deposit, I don't think it is working. So let's go to dashboard block, deposit event. Yeah, this is okay. Web3 client.call this. Has it happened or not? So we don't know. So something would have gone wrong, because I don't think this should work, because reason and amount should have been in big end. Maybe that's not creating an issue. Let's just, okay, so something is going wrong, because it is pausing. So uncaught exceptions, let's remove it, and now let's hit, yeah, see, something is going wrong. Okay, big int, yeah, exactly, this is the case. See, int we have to convert into big int, right? So let's do that. So convert, okay, big int dot from, right? So let's do that. Amount, cut it, big int dot from, paste that value. That's it guys, nothing else. Okay, I think this is done. Now let's just refresh it once, right? And let's click on credit our address. Let's just copy this address, paste this address right over here, allow paste, enter the amount, let's say 1 Ethereum, enter the reason, let's say vegetables, and click on deposit. So nothing I've got because I was not expecting anything, but yeah, let's just refresh. And no, so something has gone wrong because I should have seen a transaction here, right? So let's try to debug it. So one thing that we have to do first of all is we don't need this address, because if you see the contract, we are not accepting any address from the client side because we are working with our own contract address itself, right? So let's go in the dashboard, not yeah, dashboard page, deposit page basically, and comment this text field out. We don't need this address controller, and yeah, we only need the amount and the reason. And same goes for the withdraw. Comment this thing also out, and also let's call, or let's pass a dashboard block to withdraw page, dashboard block, dashboard block. Let's generate a constructor and let's wrap this container with the inkwell, wrap with the widget inkwell on tap. Let's bring the function from the deposit, right? And let's just paste it right over here in the withdraw function. Yeah, and this will be dashboard withdraw. Let's bring the widget or the event from here and let's paste it here. Transaction model, let's import, right? Amount and the reason, right? These two things are required. Let's pass a dashboard block to this also. Refresh. Now let's try to debit once. So let's debit 0.5. Reason, let's say veggies, right? Veggies. And let's click on withdraw. So see, something is wrong actually. Invalid radix minus 10 at character 1. So something is actually wrong. If I go to block and if I try to go to the withdraw event, transaction model dot amount, so yeah, definitely this will be converted to big int dot from. So this is your amount and this is your reason, right? If I go to contract, so deposit amount and my reason, correct? Amount and my reason, yeah, this is all good. So why are we facing some issues? Let's try to refresh this. Let's try to debit again. Amount, let's say 0.1. Reason, let's say veggies. Something is wrong. Something is wrong. Let's go to withdraw page itself. On tap, and we have this. Yeah, this is okay. Invalid radix minus 10 number at character 1. Let's go to contract. I'm taking the amount, I'm taking the reason. Perfect. Require balances at message.sender should be greater than and equal to the amount, otherwise insufficient balance. So I think the balance is still like 0 or something. Balance is not getting updated from debit, from the deposit. So something is wrong. If I go to balances message.sender, let's try to deposit again, credit, enter amount, let's say 10 Ethereum, enter the reason, let's say again wedges I put here. Something is wrong, like I'm getting this log and empty, so that is fine because I don't expect this deposit function to return anything, which is fine, but they should actually deposit the money also because I'm not able to see this thing. So the issue I guess it is in deposit function and the withdraw function, because the way we are handle it is not correct, because this call we use whenever we want to get some data, right? So we have to use the call contract function, and we also need to do the send transaction function, because here we have to send some money. So this whole thing is actually wrong, right? We just copied it from the above, but that is actually wrong. So let's just remove it, and from here what I can do is I can say, first of all I'll have a try catch block, and in the try catch block I'll say final transaction final transaction is equal to transaction dot call contract. The contract will be your deployed contract, and let's just close this. Yes, the function will be the deposit function. The parameters will be the list will contain big int dot from your event dot transaction model dot the amount, right? And then it is going to contain your reason. So event dot transaction model dot reason, right? So this is correct. Now the next thing will be the value. So after this there is a value parameter. In the value you have to say the ethereum amount. So ethereum amount dot in way you have to pass in way is another type of way of currency, you can assume, right? So you can see the conversion, like one ethereum is like how many in ways, right? That you can check on the internet. Big int dot from and then your amount. So event dot transaction model dot amount. So this you have to do whenever your function is payable. So this function is payable because here we are transacting the real ethereums, right? So after this you also need to get the result. So final result is equal to your await web3 client dot send transaction. The credentials you have to pass, and the transaction you have to pass, right? So that's it. Chain id is also something that is present, but this you can pass it as null. And then you have fetch chain id from network id, that you can pass it as true, because this is going to directly fetch the chain id from your network id. So this is all good, right? So that's it, guys. That's what we wanted, and this is all good. Now just for uh, getting like being sure, let's just print or log the result dot to string. And in case of any error you can actually handle that error, right? So let's just log this error, and you can work with some states to handle this error, right? So this that I'm giving you one simple homework. So this same thing we will be doing for withdraw, but let's just do for this one for now, right? And let's just refresh it, and then I'm also going to click on credit amount. Let's say I'll put 10 ethereum. Reason, let's say I paid it for vegetables, right? And let's click on deposit. So error, got 32,700 with message invalid signature v value. Okay, invalid signature v value. What can be the issue? So one thing that we can do is sender address we have not pass from ethereum address nonce maximum gas price. Uh, let me just copy this and put it on ChatGPT. Let's just copy it. And is ChatGPT open here? Let me see. Let me bring it from here. It's open on the next tab. Yeah, so here is your ChatGPT. Let's just put this issue. So RPC message invite typically indicates an issue with the signature provided when interacting with the Ethereum network. Incorrect signature format and incorrect encoding, incorrect private key, network configuration. Okay. Nonce mismatch, gas limit, gas specified in the transaction are reasonable and within the acceptable range. Network congestion, that should not be the issue. Network configuration, Ganache in Fura is properly configured. In double check the RPC endpoint. Yeah, that is all correct because this is my Ganache. If I go to accounts, if I check out the private key, let's just copy the private key again, and if I just check it and paste it again here, yeah, no, I think it has changed. So let me just paste it. Okay, it got changed. Let's just save it, and let me just refresh credit. amount 10 Ethereum, reason let's say again veggies, deposit. Again I'm getting the same issue. So what is the issue? Private key, credential is equal to Ethereum private key dot from hex. So this is okay. Ethereum address, contract address is D0. Let me just check it. This is the private key. Yes, transactions. This is the contract creation, and A9 contract address it is. Okay, contract address also is changed. So let me just copy this and contract address. So this, because I compiled it and migrated it again, that's why I say it's not like that it changes so frequently. It's not like that, it never changes, right? But I compiled it and migrated it again, that's why it is changing, so don't worry about it. Okay, so this is it, and now I think everything looks good to me. Ethereum address is CB. Yes, let's just refresh. Credit, enter amount, let's say 10. This time it should not fail. Again we have got the same issue. What can be the issue? Let's see. Contract address is correct now. Contract address is A9. Created contract, yes, A9. Then I'm having this balance Ethereum address dot from hex. This is the like my wallet address, or my address CB. Yes, this is correct. Then I'm having nothing. So this is all good, right? No issues here. Balance data is correct. Transactions data, web3.call, parameters, yes, this is correct actually. And then I'm having the next deposit event. In the deposit event, web3 client.send transaction credentials we are getting from here, and we are updating the credentials here. So this is also correct, right? So this is also correct, and I should not, yeah, I think it's correct. Like, what is the issue? From Ethereum address, this should be client will use the address belonging to the credentials used to the to this transaction. Let's say Ethereum address dot from hex, and let's just provide it this address, right? Let's just paste it, and I think gas value and everything it should automatically take actually. Maximum priority fee nonce, yeah, I don't think it is a problem. If I just refresh, should not create any issue though. Let's say 1 Ethereum. Something is wrong, everything is not correct, something is actually wrong. So the only thing that we had to do is, in the send transaction function, right over here, you just define the chain ID as 1337 instead of null, and define the fetch chain ID from network as false. So this was the issue. I researched on Stack Overflow and finally got the issue. So basically this chain ID is coming from nowhere, but it is coming from your Ganache, right? If you go in your settings, from there in the chain you can get your chain ID. Basically it is set to 1337 by default. You can use that. Okay, finally I got the issue, and now what I can do is I can refresh this. So one issue we are getting, because Ethereum address is not a subtype of string. So what we have to do is, over here, right, in the transaction model over here, yeah, so yes, so this one we are getting as Ethereum address, not as a string. So what you have to do is, from Ethereum address we have to convert it into string. So for now I'll just say dot to string, but there is a way of converting. Let's see on ChatGPT. But yeah, this is okay. And if I just refresh now, yeah, so you see this is the 1 Ethereum, the transaction which I did, and I can see my transaction over here. So let's try to make this data as dynamic instead of static. So go to UI dashboard page, and over here I have hard coded this data as transactions. Yeah, 1 Ethereum will not be 1 Ethereum, it will be success state dot transactions at index dot amount dot to string plus ETH, right? And this constant will be gone. Copy the same thing and paste it right here. right? And this will become address instead of the amount, address, and remove the constant from here, right? And NFT purchase, this is the reason, and this will become the reason, right? Remove the constant from here, save it. So this is the thing, guys. This is a transaction. Now if I try to add one more credit, so let's say, and over here in the Ganesh, if I just go cancel it up, you see some gas fees is also getting consumed because I'm actually making a transaction, so gas fees will be consumed. So if I do the same thing, enter the amount, let's say 10 ethereum this time, enter the reason, let's say I purchased Tesla car, right? And deposit, right? So this is going to be deposited. I can refresh, right? And you are going to see 11 ethereum, and this is two transactions. So what we can do is the container, we can add a margin constant edge insets dot only from the bottom, let's say 6, and this is okay. Okay, so this looks good. Now I can see the reason, I can see the amounts which are getting transferred, right? You can use all of these accounts also, guys. You can use all of these accounts, right? So that is your way, like how you do it, that is your task. But now I'm currently working with only one single account, right? So that's the thing. And now what I'm going to do is I am going to do the debit thing. So the same thing, go to dashboard block and copy the same exact thing, copy it up and paste it right here, call contract, same thing, function will be withdraw this time, and deploy contract, transaction model amount, reason, amount, web3 client send transaction. Yes, everything looks good to me. Okay, now I'm going to refresh it once, and let's call the debit. Let's say I want to debit 5 ethereum. Reason, let's say I purchased Tesla, withdraw. Okay, so there is again issue VM exception while processing the transaction revert. Let's try to debug this now. So let's try to see what can be the issue. So one thing is, I don't think we need value here, because this is not a payable function, so value can be removed. So you just withdraw 5 ethereums and say, oh, we got it. So I think that last time was something like uh, some issue or something. Just for a second, because I did not change anything. I think gas limit issue can be the case. So if I just refresh this time, I think the balance should be updated. So I don't think we have any issue in our code. Our code is perfectly fine if the balance is updated. Yes, the balance is updated, and I can see the transaction also 5 ethereum. Okay, guys, so that's what we have done. Now last thing I'm going to show it to you, that is when I debit or credit, it should automatically come back and it should automatically refresh the page, right? That's the only thing that is pending, and our bank or our expense manager is now ready. And I'm going to give you simple homework, so stay tuned. So first of all, in the deposit, once I do this, the deposit, what I want to do is I want to get back. So navigator.pop I'll do here, right? And I'm going to do the same navigator.pop on the withdraw function, withdraw navigator.pop. And over here in the block, when I'm done doing the dashboard, deposit and withdraw, not done, yeah, done doing, I'll say I'll just add the initial fetch event again. So add dashboard initial fetch event, right? This will automatically again call the initial fetch event and it will refresh everything. Okay, so let's just paste it here, save it, and let's refresh. We are all set. Let's see. Let's try to add some 10 ethereums. Refreshing, taking some time. It takes some time to connect with the RPC. So let's wait. Okay, so let's try to add some credits. So let's say I want to add 10 ethereums. Let's say the reason is I just want to I just got salary. So salary, and let's click on deposit. So it is going to get back and it is going to refresh the page. So let's see if it refreshes. So taking some time, and I can see the updated balance. So see, everything is working fine. So here we end the course or a mini bootcamp of Flutter plus Web3, and we learned so many tools. We learned Solidity, we learned Truffle, we learned Ganache, and we learned how to connect through Web3 Dart package. So this was a whole good project, guys. This was a good project. Now you can do some stuff. The stuff that I want to do is it should actually show whether it is a credit transaction or it is a debit transaction. So for that, you need to go inside your smart contract, change the transaction model. It should also store whether it is plus or minus, whether it is like added or removed, and so that we can show here a red sign or a green sign, right? So this is your homework that you have to do. Take a screenshot once you're done the homework and put it on LinkedIn, tag me or send me or you can also put an Instagram story, right? Just don't forget to tag me. I'll be happy to reshare that or comment on that, right? So great, guys. It was nice working with you or learning with you. I learned a lot today, right? And don't forget to check out this whole thing is also uploaded as a course. Do check it out if you want to. If you get some doubts or chat, you want to chat with me, then that course is helpful instead of just watching the YouTube tutorial all at once, right? Next thing, if you want to learn full stack Flutter, full stack development from me using Flutter plus Node.js, Express.js, MongoDB, Postman, and Render, then do check out the course in the description. That is a full stack mobile app development course, right? So I hope you like this whole thing. If you want me to make another app, any kind of other app, AI app, blockchain app, AR, VR app, just put that in the comment section, whatever you want to learn, right? So see you guys in the next video. Do check out NORDEK also, their NORDEK Genesis program. That is also great. So see you in the next video. Till then, keep coding, keep innovating, and thanks a lot.